Hello everyone and welcome to the 9th lecture of this Python from Scratch course. In today's lesson we're going to learn about two new ideas present in Python, and those are dictionaries, a new data type to store our information, and how we can import modules to bring useful functions and useful functionality into our code. But first, let's start with dictionaries. Dictionaries are a very nice step forward from lists, which we learned a few lessons back. Lists allow us to store information in a nice and ordered manner, but dictionaries allow us to store not items one by one, but key-value pairs. So what do I mean by that? In a list you have item 1, item 2, item 3, and so on until the list ends. But in a dictionary, each element in your dictionary is going to be two elements actually, a key and a value. And unlike in a list, dictionary is not ordered, so you will not be able to ask Python, give me a fourth element of my dictionary, because elements in dictionary are unordered. You will be able to ask Python, give me an element in the dictionary with the following key, and that's how you will be able to access information in your dictionary. So let's have a look at how we can use them in our code. There are multiple ways you can write information in dictionaries, and let's have a look at the first one. On line number 2, we have created an empty dictionary called plate numbers, and we don't give it any information. It's just curly brackets, meaning the dictionary has been initialized, but it doesn't have any information. If we were to print plate numbers straight after this, and let's comment out everything else for the time being, we would just get an empty dictionary because it's empty. Now that the dictionary has been created, we can store values into it. And as I said, we cannot just store an element. It has to be a key value pair. And the way we do that is using square bracket notation for the key, and then equals whatever we want to store as a value. It could be a string, it could be a number, it could be a list, it could be another dictionary, it could be whatever you want. But for this example, we are storing strings, string-to-string key-value pairs. So I call my dictionary plate numbers, so obviously I'm going to store plate numbers in this dictionary, and I have 3 elements which I'm going to add to there. Alice, Bob, and Charlie for keys, and plate numbers for each of these people, obviously representing the plate numbers and their cars. And let's see how it is stored in a dictionary. Let's print plate numbers on this line and comment everything else. And that's how it's printed. So that's how our dictionary will be stored in memory in key value pairs, Alice, double dot, and the value associated with this key, Bob and his plate number, Charlie and his plate number. Obviously, if we wanted to add another element, we would do as such. Donnie equals another plate number. And let's make it MS3456KS. And if we were to run it again, now we can see we have all 4 elements stored in our dictionary. Notice you cannot have elements with the same key repeat in your dictionary. Keys are the unique identifiers which are going to be used in order to find the elements in our dictionaries. Therefore, if we actually tried to store a different plate number for Alice, like if she had 2 cars, and if we were to run this code, as you can see, we don't have another Alice in our dictionary. We just have overwritten the value stored for key Alice in our dictionary. So be careful with that. Dictionaries are not the best use cases for that, but in the scenarios that I just described, we could do a list for Alice, and let's uncomment this line. And now, as you can see, for the key Alice, now we have a list stored for her, and we have 2 plate numbers there. And for Bob, we only have 1 string, and as well as for Charlie. So that's how we could go around this problem. Let's delete all of that so it doesn't confuse us. So that's one way you can store information to a dictionary, and now let's have a look at the other. And let's uncomment all of this. Another way we could initialize our dictionaries is straight away give it all the information we want to store in it, and then later we could add additional information using this notation. So in this example, we immediately open the curly brackets, which initializes the dictionary, and then we just immediately give it all the key value pairs that we want to store it upon its initialization. And it will have the same effect as we have just seen. So let's print it and make sure that it does indeed work. And yes, as we expected, Alice and her plate number, Bob and his plate number, Charlie and his plate number is printed. So they are stored in memory as expected. So that's how we initialize and write data to a dictionary. Now let's have a look at how we can actually access data in the dictionary. As I said, we don't access them using indexing anymore. In lists, each item had an index 1, index 0, index 3, whatever. And in a dictionary, we can access them using keys, or we can iterate over every element in the dictionary using the following notation. So we use for loop, and now we do for name, plate number. Again, this could be I and J. It doesn't matter, but obviously name and plate number are more self-explanatory. So we do prefer to use self-explanatory variables. And then we use the in keyword to iterate over our dictionary. But our dictionary in itself is not iterable, so we need to use .items function of our dictionary in order to access each item in our dictionary. And let's see how that works. So now as you can see, we iterated over every element in our dictionary, and the following line was executed: print name, plate number. So we printed the key and we printed the value. Maybe this will be a better naming convention for these variables for the purpose of this tutorial, because what these elements are actually in dictionaries, they are key and value pairs. But obviously, when you start writing more complicated code, it is very useful to use self-explanatory variables. Now we know how to iterate over our dictionary. Let's actually have a look at how we can delete items in our dictionary. So in order to access an item in our dictionary, we use the same notation we used up here, using the square brackets, and we can use a del keyword to delete that key value pair. And if we run it here, so we initialized our plate numbers, we're gonna delete an element with key Alice, and we're gonna print our dictionary. We can see that Alice is no longer there. And if we were to change it to Bob and run it again, we can see that Alice is there, Charlie is there, and Bob is not there. So that's how we access particular elements we are looking for in our dictionary. And this is just another data type that you can use in your programs depending on the scenario you're currently working on. Obviously, for certain scenarios, it will be better to use lists, which you can iterate over easily, and each item has an index which you can use to find your element in the list. But for a different scenario, for example, for plate numbers, or if you wanted to store a phone book maybe with names and the phone numbers associated to those names, then dictionary would be a much better choice. So make sure you analyze the current scenario you're working on before choosing which data type to use in order to store your data. Now that we have learned about dictionaries in Python, let's go ahead to the second topic of today's lectures that I wanted to discuss, and that's importing modules and packages into your Python program. So, as you might have guessed already, you don't need to reinvent the wheel every time you're writing a Python program. You don't need to figure out how to do a sorting algorithm or how to do a certain mathematical function. Most of these have been already encountered by programmers before you, and therefore you can just use that code in your own Python program very easily. So let's do that. The way you incorporate functionality from a different Python file or from a different Python module is using the import keyword. What import keyword does is it tells Python, please go and find this piece of information and bring it within the scope of this code, so that I can access the functionality in that module in my code. Let's have a look at the mass module actually to see how it works. So what we are telling Python is go and find the mass module, and mass module is a standard, well-defined module in Python which you can freely use. And obviously at this point you don't know what modules are out there, what modules are available, or what modules you can use. So in order to find out about that, what you would do is you would go to Google and literally type import mass Python. And the first link is the official Python website, which will tell you about the mass module and all the functionality within it. So as you can see, it is quite a massive file with quite a bit of functionality with different functions, and each of them is explained. Let's have a look at the floor function. So mass.floor takes one argument x, and it returns the floor of x, the largest integer less than or equal to x. So let's see how we could use that in our own code. We have just imported mass, and let's print mass.floor 1.49. And it printed 1. So what we did just now is we said go to the mass module we just imported, find the floor function inside of it, and pass 1.49 to it. And what that function returned was the floor of 1.49, which is indeed 1. And if we do 2.49, it will return 2. Minus 2.49, it will return minus 3, because it just finds the lowest integer below the argument we pass. Obviously, there are quite a few functionality here. You can have a look through it in your free time. We are not going to go through every single function that the mass module offers. But one very important idea to consider when you're importing different modules into your code is sometimes you're not going to use every single function in that module. And if that is the case, it might be better to only import the functions you are going to use and use those instead. So the way we can do that is using the following notation: from mass import floor. So what this tells Python is go find the mass module and only import the floor function from it into our code space. And once we've done that, the floor is actually defined in our code, and we don't need mass dot before we call this function. And as you can see, it all works as expected. If you wanted a different function like is finite, for example, to check if the number we are passing is finite, we could do it as such. Is finite 6.49. 6.49 is indeed a finite number, therefore we got true. So that is the mass module. Obviously there are many more modules out there, and when you're faced with a problem, you don't, most of the time you will not need to reinvent the wheel. As I said, you can go and have a look at the code done by your predecessors, and in more situations than not, you will find that the problem you're facing has been solved before, and therefore you don't need to spend much time on it. Obviously make sure that the code you're using in your code is not protected by copyright laws and it's free to use, but besides that there's not much for you to worry about, and you can use it in your code. Anyways, that's everything I want to talk to you about today. We have learned about dictionaries, a new data type, and how to use it. We have learned about importing modules into our Python code and using them in our Python code. Obviously you can write your own modules, but we haven't got to that yet. But it's not too difficult. Writing your own modules is you literally just write a Python file with some functions, and then you can import it into your code, assuming you know how to get to it. So if you had two files in the same folder, you just have to specify the way to get from your current file you're working inside to the module you want to import, and that's it. Anyways, that's it from me for today. Next time we're gonna learn about programming rules and good practices when you're programming. And I'll see you then.